Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello there and welcome to the episode. Today I'm joined by Thomas and Antonio from German deployables company Deployables Cube. Deployables Cube creates actuators and deployable mechanisms and other similar technologies for a wide range of missions and a wide range of different form factors and application areas. So today we're going to talk a little bit about the use of deployable solar arrays, specifically for CubeSats. So Thomas, Antonio, thank you very much for being here today. Is there anything you'd like to add to that introduction?
Yeah, we are very excited to also be in the podcast again. And it's a very perfect time for us because we just passed the MRR, the Manufacturer's Readiness Review of our big solar array, and now gearing up for the testing and then preparing the flight mission. So perfect timing.
Yes, thank you very much. Yeah.
Great, thank you. Well, we can get into hopefully some of those details. Firstly, I think I'd like to set the scene and ask what sort of bottlenecks do CubeSat teams face that make a case for using a high power deployable solar array solution, and maybe an overview of what sort of missions and teams do you see adopting such technology for their own uses?
Yeah, the thing is with the NewSpace transition, as I mentioned also in the other podcast, is that we are getting into building more and more satellites that have a standardized size, and therefore they can be launched cheaply, built cheaply within just a couple of weeks. But when we are going up into space, we normally need bigger structures. And one of these key areas is to have enough power for standard computers to run these advanced missions. One nice example is that's why we also are working on PowerCube is the need for power in communication. So building up IoT application in space, but also space to space and space to ground communication requires quite a lot of energy. And therefore, we need deployable solar arrays because the area that we have available on the CubeSat is not sufficient anymore. Other applications we clearly see in electrical propulsion because we see more and more thrusters coming out that require quite some kilowatts of power and that they can run continuously. We need big solar arrays to generate power.
Okay, interesting. Yeah, that makes sense. Obviously, a piece of technology that is as complex as this in the space environment will have required you to bring together a few different areas of innovation, essentially. I wondered, Antonio, if you could give us an overview of what those areas are that are making, high-power deployable solar arrays a viable option for the sorts of missions that you've just mentioned.
Yeah, sure. So when we started working on our high-power solar array development, PowerCube, we quickly realized that conventional architectures weren't working for us because normally when you have, a standard off-the-shelf solar arrays for CubeSats, you end up with foldable panels that are injured together. But that only gives you about 20, maybe 50 watts of power. But then we were aiming for 100 watts. And we realized we really had to rethink entirely the way to build it because otherwise it would have been too big and too difficult to maneuver for the satellite. So we had, first of all, to use quite advanced deployable architectures. So instead of having these foldable panels in one dimension, we are using now origami structures. And using origamis, we can basically create an approximately square area and we can stow it in a cube. And in addition to that, we also needed advanced materials. So in particular, our solar array is self-supported by a carbon fiber reinforced structure where we are using a dual matrix composite. So basically, it's a type of structure that we can build all at once. So there are no mechanical articulations. And it's very rigid where the solar cells are mounted. And it's also very flexible along the folding pattern of the origami. And basically, by combining these two components, so origami architectures on one side and advanced composites on the other, we achieve very high packaging efficiency for our structure, which enables up to 100 watt or even more power on a simple 3U CubeSat.
Brilliant. So advanced materials and an innovative method of storing and deploying them. Really interesting. And you mentioned the power rating there being, a lot higher than what is often produced by the solar panels in a CubeSat. But with that amount of power being produced, that needs to be managed in the small volume of a CubeSat, a 1U, 3U, 12U, whatever it is. Do you foresee any challenges particularly in thermal management that need to be solved alongside the development of the arrays themselves?
Yeah, of course, like thermal management becomes really critical when you start developing high power satellites. And if you think about it, even if CubeSats have relatively limited power, the power density that you get, it's a lot more than big communication satellites, which means you're dissipating a lot of more power for the same volume. So the way we are tackling this problem on PowerCube is to thermally decouple it from the satellite. So basically the heat that we generate doesn't get conveyed to the subsystems. But at the same time, of course, it's going to be a problem for the CubeSat users, and especially normally they have a very power-hungry payload. It could be, for example, an electric thruster. It could be an LED or a laser for communications, or just a PCB. And in that case, they will generate a lot of power that needs to be dissipated. And for this reason, we started recently working on a passive deployable radiator, which is not going to be part of PowerCube, but it will be sort of an add-on that could be placed exactly where a customer needs it. And it's going to be sort of a passive design that you can simply deploy next to the power generating component, and helps you radiate it away.
Dealing with the power and the thermal issues are as important as the amount of power you can generate, of course. And we see trending topics in the industry where subsystem manufacturers or the satellite integrators are looking at both areas. They want to use more innovative payload, as you said, power hungry payloads. And in order to do that, they need to create an architecture that's efficient so that they can reduce the power consumption that maybe they've had previously, and B, be able to produce more power. So that's great. But obviously this is the space sector. So the space heritage of the component of the system is always going to be very important. Thomas, you mentioned some of this in the beginning, but Antonio, what's the roadmap for getting the space heritage for PowerCube, and what kind of, assuming everything goes well, bringing it to market, what kind of customization options are you going to be able to offer within that space heritage envelope?
Yeah, so as Thomas mentioned before, we recently passed the MRR. So right now we are building our engineering model that will go through all the environmental testing campaign later this summer, just to demonstrate that it's going to work as intended in the right environment. And after that, we have an IOD mission planned in 2023. It's a mission with Cal Poly in California. And they are basically developing a 3U satellite for a space solar power demonstration. So basically they have this 3U satellite. They have a very powerful LED, and they want to demonstrate energy transfer from space to Earth using light. And of course, for that, they will need our solar array, and they are also developing all the payloads. We also have a propulsion system on board. So we were awarded a NASA Lana launch for this project. So we basically already have a launch, and it's planned, as I mentioned before, for the end of 2023. So we're really excited about that, and we're really looking forward to our demo.
Yeah, and I think I also want to jump in here because one of the things that we want to do quite early on is to get customers involved that could use this technology. Because only if we make it based on customer requirements, we can be ensured that there's also a market for it. We did it with the actuators, with our selfie stick, and now with the PowerCube as well. So here's also a call out to anyone that is still interested in flying this technology or needing it. Just get in touch with us.
Great, thank you. Yeah, and then just to ask about, just as I mentioned, about the customization options that you are intending to offer. Obviously, within, as I say, within the confines of the space heritage you're able to acquire, but also, as Thomas mentioned, based on customer requirements, I guess.
Right, of course. So we have a couple of options in mind. So first of all, the solar array is meant to be scalable, which means that we can adjust the power that we generate to the customer's needs. And then, of course, I will say making it smaller, it's very easy, but we can also grow, I would say, up to 20% and more powerful. In addition to that, we are developing a maximum power point tracking PCB as an add-on to our system. So basically using this, you can basically match the performance of your solar array to the need of your payload, which means basically always getting maximum power from the solar array. So this will not be part of the main product because sometimes MPPTs are on the electrical power system on the satellite, but we think it's very useful to provide it as an add-on if needed. And in addition to that, we are also thinking of adding some ways to access the top of the satellite for mounting sensors. Because as you can expect, we have this pretty big solar array that is covering entirely the sun. And sometimes people may want sun sensors or other sensors on the top face. And we want to provide a way for people to easily do that. So this would be, I would say, the main customization options that we have in mind at the moment. But of course, like we're always open to feedback from the customers to see what is really interesting for them and if we can actually accommodate additional features.
Brilliant. Yeah, the position of the sunsets here obviously is a key challenge. So that's great that you're thinking about that. And you mentioned the scalability of the system there, but with the Power Cube is stored, I believe, in a 1U for form factor. How do you foresee it being used in larger CubeSats, such as 12U or 16U systems? Particularly, I'm thinking about, balancing out moments of inertia and other such considerations that need to be balanced where payloads are typically stored.
Right. So the form factor for Power Cube is naturally like 1U because it's a symmetric structure. So it really needs sort of a square configuration. Now, if you look at the bigger satellite, our suggestion would be always to mount it at the center of the back face, so that basically you don't get a cross moment of inertia, which means that basically during the accommodation of the payloads, you basically have to put the PCBs on the two sides. Which is also partially what is done by people already for similar systems. And this basically allows you to balance the moment of inertia. Also, you have to keep in mind that you have this large deployed area, which means that especially if you're flying in low Earth orbit, you basically get quite a bit of drag. And so it makes sense to have the solar array on the back face of the satellite so it gets naturally perpendicular to the velocity vector along your orbit. So it kind of stabilizes it and also in a way acts as a deorbiting device.
I think that was most of the technical questions there. Just maybe a final question to Thomas first. Obviously, Antonio, feel free to share your thoughts too. But Thomas, what are you most excited about seeing happen in the industry in the next few years? I think DcubeD has been involved in a number of quite interesting missions, and there's a lot that you guys are working on because of the nature of the technology you create is quite, widely applicable potentially. And yeah, what's next for DcubeD itself?
Yeah, I think it's the best time to be in the space industry right now, since the moon era in the 60s, because right now we see so much development all over the world. And what has been planned over the last years is now coming to its fruitful launch, because when you see how many companies are loaned here in Germany, in Europe, that are developing launchers that are having the possibility of bringing satellites cheaply into space, it will open up so many opportunities for in-orbit demonstration, for really exciting missions, be in low Earth orbit, going to the moon or going to Mars or deep space. And that's the exciting thing of being a component and subsystem supplier like DcubeD, because we are actually can be part of these exciting missions. So we're not building a constellation where we are just staying in low Earth orbit, but we are supporting the companies that are doing that. They are building up their IoT constellations, their Earth observation constellations. But then we are also part of missions that are dropping a rover on the surface of the moon to prepare for the next man and the first woman on the moon. But then we are also having projects where we go into deep space. We're looking at asteroids. And there's much more coming in the next years, because a lot of companies are out there which are looking at more out there business cases. And directly for us, next to the moon mission and the deep space mission, we are very excited for actually launching our selfie stick again in October, and also then launching PowerCube next year, and then also doing some more radiator development and trying to get on much more missions. Our goal at the end is to have our products on every space mission, to go everywhere where the human race is going into space.
Fantastic. That's great. Yeah, as you say, I think the analogy with the micro launchers technologies is really interesting. That's a key enabling part of the industry. And I think the sort of work that you guys are doing by enabling small satellites to have increased power, and by giving them more functionality through deployable systems, and yeah, obviously you mentioned the wide applicability of the technologies that you create to all sorts of different types of missions are also enabling factors in themselves. So best of luck with all these missions and all the progress at the company, and thank you very much for sharing today the insights on the topics that we discussed.
Yeah, thank you very much for giving us the opportunity. It was a great pleasure, and I cannot wait for the next time with the new developments that we are doing.
Thanks a lot.
Absolutely great. Well, thank you, Thomas. Thank you, Antonio. And to all our listeners out there, thank you very much for spending time with us today on the Space Industry Podcast. And if you'd like to find out more about DcubeD and all the work they're doing, then please look out for them on the internet. We'll also share links to some of their satsearch pages and content in the show notes. As Thomas mentioned, please do get in touch if you have any potential use cases or ideas to discuss how the use of greater power solar array technologies could be implemented in your own services or missions. And we will speak to you very soon on the Space Industry Podcast. Thank you for listening to this episode of The Space Industry by satsearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.